Hello, welcome to this lectures on socket programming. In this and the next lecture, we will discuss UDP and TCP socket programming. In this lecture, we will primarily work on UDP, and the subsequent lecture will work on TCP. The basic resources, first article, the first reference is an article by me and Professor Viraj Kumar talking about in general how TCP socket programming works. There are few sample documents, and the we also have some reference program which I'll be using, which you can access from. Look at my website, which is rprustagi.com slash workshops slash programs. So there you can find the sample program which we'll be using in this course of the lecture. So let's look at what really a socket programming is, what a socket means, how do we use it. Primarily, you look at as an in socket as an interface between the application program versus the network layer, transport layer. It's something like you look at, let's say you want to send a courier a letter to one of your friend out somewhere else. So you basically ask courier guy to come and pick up. So courier person comes to your door, and at your door you give the letter to the courier. Now courier, whatever means it uses, transport, road, rail, or air, whatever, and finally delivers this letter at the other end to the door of the recipient. So socket is, you can look like more of a door between your house and the connecting street or the world. Same way, the your the socket in our network is a kind of a door between application process and the network underlying protocol. So example, you can probably look at that these are my transport layer, transport, network, link, physical. Then the application layer, my process runs. So the way the process talks to the transport layer, we define an interface point, which is called a socket. So both sides, the sender and the receiver and vice versa, you have this. And essentially, we look at it is an API interface between application process and the transport layer. We look at. Please note that these bottom four layers, transport, network, link, and physical, these are controlled by the OS. Only the application part of it is what you write socket program, and API supports only these calls. Primarily, we define a socket, as I said, is an interface, application interface. You write into the socket, you read from a socket. Socket basically gives you more like a file abstraction. So if you look at the Unix world, every IO that is done is the more like a file. You open, read, write, and close. Same thing will happen. Once you create a socket, it kind of gives you handle like a file IO, and then after opening creating a socket, now it becomes like a file handle or file descriptor. You write into this file, you read it from this file, and finally you can close it, and that's the way it works. First time this socket implementation occurred with BSD Unix or Berkeley System Division Unix, and since then it has become popular, and now it's actually practically the whole socket implementation follows the BSD implementation only. A machine is identified by the IP address, and we get into more details when we deal with network layer and the transport layer when get into more details port. But for the brief for socket programming, so remember, a machine could be running multiple applications. So even though all applications on the same machine, they have the same IP address, but OS should be able to distinguish that message received from which application. So basically use what we call port number. So port is what binds an application to a given port, and based on the port, OS decides to which application the message needs to be delivered. The well-known applications which we use, something like a web server, FTP server, SSH, Telnet. So if you access web, when you run open a Google browser, sorry, when you open a browser, access google.com, Google server runs on port number 80, or if you are doing secure access like HTTPS, it uses port number 443. If I'm doing SSH to a given machine, secure cell login, it is port number 22. If I'm running FTP, FTP uses port number 21. So that well-known ports, so these ports less than 1024 are reserved for well-known applications, and typically client like a browser also needs to have port to receive a message, and these port numbers for the application like browser, which can be dynamic, it doesn't need to be well publicized. There is anywhere from 49K to 65,000, though this the normal one, but that doesn't mean a client cannot use any other port. It can, but the general recommendation, the port less than 1024 are reserved for well-known. Port numbers between 1024 to 49K is can be basically allocated, but can be used otherwise as well. To look at which sockets are running or which sockets are opened, you can run a command netstat called network status. Minus n is for don't convert name to sorry, IP address to host names. A is all the details used for UDP, and for TCP we basically use minus T is for TCP option and U is for UDP option. And we'll look at those, and we can use other there. We'll have some basic Python program, but we'll also run NC to look at how to make UDP communication. As you said, we have two kind of sockets, UDP and TCP. In this lecture, we look at only UDP. And the general notion is UDP is said to be unreliable, TCP is said to be reliable. These two are kind of misnomer. Unreliable does not mean that everything is completely bad. So notion of unreliable has certain context. It basically means message could be lost, or the message could be delivered out of order, but normally message is not corrupted. So unreliable does not mean message can be corrupted. Same way TCP is reliable. Reliable does not mean that reliable is different from guarantees. This is what the common misconception a lot of people would have. So when a client sends a message, is not guaranteed that message will be delivered. What TCP guarantees is that if and when it delivers a message, it will deliver in order, uncorrupted, no without loss, and in order. That's what basically it means. In our example case with socket programming, we'll write a very simple client program and a server program. A client would read a number of characters on the input console like stdin, and then sends the data to the UDP server. UDP server would receive the data, convert into uppercase, and send it back to the client. And when client receives the data, it will display it on the screen. Very simple example, and we look at so that we understand how the socket programming works. So let's look at the basic what you want to do with UDP. As we said, UDP perspective, there is no connection between client and a server. All the client needs to know is what is the server IP address, what is the server port number, and then it will just send a message. That basically means there is no handshaking involved between client and a server before sending a message. It's something like if I want to send a letter, mm, I can simply write the two address on the letter and drop into the letter box. I really don't care. I don't do handshake whether other guy is there or not there. But when I make a phone call, I dial a number, make sure connection is established, and then only once I get hello answer, then only so I send a communicate start communicating. So UDP is more like postal network for sending a letters. Each letter needs to have this address, and we just drop in the letterbox. Where in the voice, only once you set up the communication channel is established. After that, each time we don't say, "Hey Ram, are you?" and then we don't say messages for whom. We keep communicating because connection is established. So in TCP, TCP requires handshaking before exchanging, whereas UDP, no handshaking is required in the UDP. So UDP, no handshake, TCP require a handshaking, sending a data. So in UDP, a sender needs to send attach IP address and port number both with each message every time it sends the data, and we'll see that as part of the example. Receiver, when it receives the data, how does it know who has sent it? Because there's no connection established. So when it receives the data, it also gets to know which is the client's IP address and the client's port number so that it can respond back, and will display this as part of our basic examples. Please note that when data is transferred UDP, data may be lost or it may be received auto order, meaning let's say client has sent 3 packets, 1, 2, and 3. In UDP packets, it's possible that packet number 3 is delivered before packet number 2 and packet number 1 never got delivered. Though in real life, implementing received out of order may not be that easy, that require network conditions, but data loss can easily be implemented. And if you look at the references, the first article, the references I given, we talked about details, what setup can be done to implement this kind of packet loss. So in a way, from application viewpoint, it's basically application sees UDP is giving unreliable transfer of data, and again, unreliable means it could be lost, it could be delivered out of order, it does not mean corrupted packet. But when we study the actual UDP protocol, we'll see it theoretically it can be possible to corrupt the data, and this receiver would not know whether sender the data has been corrupted, but that when deal with specific cases, for the time being, will assume that UDP provides unreliable, which is only other data could be lost, message could be lost, or if client is sending multiple messages, these messages could be delivered different order than what they were transmitted by a client. So I want to look at the interaction. We have a server running, let's say a server, and then we have a client. So firstly, a server should be ready to receive data. So server basically create a socket on a given port number using a socket called socket. AF internet dgram, sock dgram indicates datagram, sock stream would be for TCP, and then is use a bind call that basically means it is telling its OS, look, this port number is not for me. So any data comes on this port number, let's say 9. For our example, we would be using the port number 9999 by default. You can change it to something else. That means any data that we receive on the port number 9999 due to this application. Client will again need to create a socket like an application interface. So first creates a socket. After creating it, let's say it sends the data, it has got some data, and it will use send data to on the client socket. And after sending it, data would go, server will receive it, it would process it, sends a reply back, then client reads it. And if now this process of sending, receiving can go on for a long time, and once client decides that is done, it can close and get out. A sample code would be something like this. This is a client code. We basically, for this is a Python program, so we need to import the socket library. So indicate from socket, import star, that means import all the socket API library call, like creating a socket, which is this, send to receive, and all the API calls. So we use the socket library. Now, I'm using the hard coding in this sample for brevity, but you can use this as your command line arguments. So we are saying now once the so client creates a socket, basically with the socket library, it creates a socket. After that, ask user to enter data on the console. So you answer the console. This program corresponds to Python 3. There's some basic difference between Python 2 and Python 3. Python 3 is a network level, make sure that data is sent as a stream of octets. So an internal representation is like stream character of data, so it needs to be converted to octets, and hence this data must be encoded into octets by using ASCII or whatever other scheme called UTF-8 before sending it, and same way you need to decode it after receiving it. So user gets the input, after user gives the input, you convert into ASCII, the octet stream, and then send it. And remember, in the send to, this is the message part which is entered, and this is the tuple which says server name and the port number, server port number. So with each message which is being sent, you always specify the server name and the port number, and the message goes to the server. Server will receive it, server will give a reply back, and then we want to receive whatever server response is. We say receive from, and this value 204 is indicating we are ready to receive response up to 2048 characters. If server sends more than that, you will see that my application will get only up to this much. Another part of data is kind of will be discarded by the OS. And once this is done, now this could be run in a loop, send and receive. And once you are done, finally you can close the socket, and that's how things would work. Similarly, on the server side of it, server would create a socket again. We create the socket. We are using by default port number 99. Server needs to do a bind because bind indicates to the OS that resolve this port for me. And that means any data that comes on this port, OS will give this the received data on this port to the given server. Now just displaying server ready to receive. Now this is a loop because server is supposed to run forever. Server reads the data from the client and it knows that, so because data is octet string is Python 3, if it is Python 2, you don't need to use this decode. So this decode required for Python 3 to convert octet into the character string what you are reading. And then after we are saying convert is a basically character string, convert into uppercase and send it back. While sending again, we need to convert into octet string, and we are calling encode. And remember, send to, this is the data, and we need to send again. We need to have the client address. Look at client address is basically a tuple, which is when they receive the data from here, the client address consists of the IP address of the client and port number. So this is a tuple, both of them I'm sending to the client address, and data would go in and server would be ready to wait for the next data and continue. So basic general observation about the Python, make sure that in the client we are sending only one message. There is no continuous. We can always write a while loop to send as many messages as we want. And the identifying a server name and server port number is a tuple that we specify in the enclosing parenthesis. Otherwise, I see a common mistake while doing, we somehow miss it. So this itself is one parameter and there are not two parameters. So sending is concerned when you say send to, first parameter is the message and second parameter is the address, which itself is a tuple. So send to has two parameters, not three. Second parameter is tuple consisting of two parameters. Make the difference, understand that part. And we already done that. I also said if we are receiving only 2048 characters, let's say we invoke a call, say only 10 characters, but other end sends me 20 characters, then OS will basically receive all the 20 from the server side, will give me only 10, and 10 will be discarded. I would recommend to, when you write your own program, look at it, how things will work out. So we'll probably give you a basic demo of how things will work out, and then you understand the way it will work. So let's go to our basic command line. So I'm running one server here and I'll be the client. So let's say I look at the program more, udp server.py. So if we look at, we are using the by default IP address 0000. That basically means all the IP addresses that belongs to this machine applicable to all. And we are seeing port number 9999. We can change it to something else, but it's the port byte number by default. We can specify by the parameter called dash port, and that's the way it will work. Now in the code, we are basically we're doing a bind to server name and port. And remember this, server name and port number is a single parameter, which is basically a tuple. And now say server ready to receive. This is while true, one is a true, it receives. And remember on the left side, we have two parameters. One is the message received, one is the client address, and this client address is basically the client IP address and client port number. Now server is decoding octet string to character string, and then it displays it here, and then converts to uppercase, and codes it into octet string and sends it back, and the loop continues. We look at a simple client program as well. It's a more udp client.py. Again, here we are putting port number is a must required, and so is the server IP address because client needs to know what server is talking about, and logic is the same. We basically say read from input console, convert into octet stream, then use server IP address and port number as a tuple, send it, receive, only one message sent, one receives. So let's run this server. We say Python UDP server dot py. So it is ready to receive on port number 9999. Now we run Python 3 UDP client dot py. Say there's the server 127. I'm working on local machine. There's port number 9999. It say hello. So I say hello, my trial of UDP communication. And you see data goes in, server conversion to uppercase, and I get this, and things work out. Now this program is sending only one message. We can put it run in a loop. So we can look at the following: more UDP client loop. So here you have just put a while loop, and we say keep read from console, keep sending it, keep receiving it, and only when you type exit with E capital, client program will come out. See, my server is still running, so I can run this program Python UDP client loop dash dash server 127.0.0.1 dash dash port 9999. You say first message, you get a response. First message converted capital, and server displays message from his first message. Let's say I say second message in UDP socket communication. You'll get the same message, get it, and then server is converting to uppercase, sending it. Now, since we have check of exit, we say exit, server exits, sorry, my client exits, and server continues to run, and that's the way. So this exercise, I would recommend you to write your own program, run it. So first is at simple Python program, you can use these programs or at your own. Second is rather than reading whatever is sending, read less characters than what you're sending, do multiple repeat and see what really happens, what happens to the remaining data. Second program would be invoke multiple clients to talk to the server, multiple 3-4 clients at the same time, and then see how the server knows which client is talking to. And server code doesn't change, the same server code, because server receives a message, process sends it and forgets about it, has no track. Just what, so a single server can handle multiple clients. In fact, this simple server code can even deal with hundreds of clients at the same time without making a change. The next exercise would be build a kind of a chat server or a chat group. That basically means connect multiple clients to a server, and whatever a message client sends, the server broadcast this message to all other clients. So something like use WhatsApp group, implement a WhatsApp group kind of broadcast, like whatever one client sends, server sends the message to all other clients, and so on, so forth. So with this, you'll probably get a basic idea of UDP socket programming. In our next lecture, we will look at TCP socket programming, which is more nuanced, and we need to get a little more fine-grained details. Thank you.